Hello and welcome to this video. Today I will show you the iteration time demand analysis under RMS to determine the feasibility of this task set. I recently showed you the graphical way, and I want to remind you that for a task to be feasible, its trajectory line must intersect or touch the dashed line slope on or before the first deadline of the task. Over here, in this way, we will start by assigning the priority. Under RMS, the tasks with shorter periods receive higher priority. So task 2 has the highest priority because it has the shortest period. Then it comes task 3, then task 4, and task 1 has the lowest priority. We use the iteration time demand formula for each task to check if it meets its deadline. We initially set the time demand to be equal to the task execution time, because as a starting point, the minimum time needed for the task to run is its own execution time. And then when we start the iteration, we can add the higher priority tasks interference. The iteration stops when the current time demand is equal to the previous one, and if it is less than the task's period, then the task is feasible to meet its deadline. Now the time demand for task 2 initially set to the execution time of task 2, which is 1. This is what we said over here. The first iteration is still equal to 1 because there are no other higher priority tasks than T2. The current time demand is equal to the previous one, so the iteration stops. The time demand is equal to 1, which is less than the task 2 period, means that task 2 is feasible. Now the time demand analysis for task 3 is set initially to be equal to the execution time of task 3, which is 2. The first iteration is equal to the execution time of task 2 plus the higher priority task's interference. And over here, task 3 suffers task 2 interference. So we use the previous time demand over task 2 period times task 2 execution time. 2 over 6 is equal to 0.33, and when we use the ceiling function, it becomes 1. So the result is 1 plus 2 equals to 3. In the first iteration, if the target task's execution time is less than or equal to the periods of all higher priority tasks, then each higher priority task will preempt exactly once. Means that this term will always be 1. Thus, the first iteration simply equals to the target task's execution time plus the sum of the execution times of all higher priority tasks. We will not consider this term and will only add the execution time of the task plus the higher priority task's execution time. So we can do a shortcut of adding only task 2 execution time plus task 3 execution time. For example, if we had task 3 execution time equal to 7, then we cannot do this shortcut because it is more than the higher priority task period, which is 6 over here. In the second iteration for the time demand, we do the same. but with the previous time demand that we had. The result equals to 3, and in this case we can stop the iteration and check if the time demand is equal or less to the task's period. If so, then the task is feasible. Now we'll do the same thing with the other tasks. The time demand for T4 is set initially to be equal to the task for execution time. The first iteration is equal to the task for execution time plus the higher priority tasks interference. And task 4 suffers task 2 and task 3 interference. So we'll use the previous time demand over task 2 period times task 2 execution time plus the previous time demand over the task 3 period times the task 3 execution time, and this will equal to 7. We can do our shortcut, but first we need to check whether our task 4 execution time is less than the higher priority tasks period. So is 4 less than 6? Yeah, that's true. Is it less than 8? That's true. Then I will add 1 plus 2 plus 4, and that will give us 7. The second iteration, we use the previous time demand and repeat the same thing as we did over here. So we're only putting the 7 here and calculating. The result now is 8, and then we will use it in the third iteration. You can see over here that we don't have any more time demand. Means that that we can stop the iteration, and we can check if the time demand is less or equal to the period. Over here it is 8 is less than 12, means that that T4 is feasible. Lastly, for task 1 we'll do the same. Task initially it is the time demand it is equal to 4. The first iteration, we can do the shortcut, but first let's check if the execution time is less than the higher priority tasks periods. Is 4 less than 12? That's true. Is 4 less than 6? That's true. Is 4 less than 8? That's true. Then I will add 1 plus 2 plus 4. Yeah, plus 4. So 1 plus 2 plus 4. And don't forget the tasks 1 execution time, which is 4. So the result is 11. In the second iteration, we take the 11 and we put it here. This is the same thing, what we did with the other tasks. And the interesting part that in the fourth iteration, the time demand is exceeding the task 1 period, and over here we can stop because the task cannot meet its deadline, and therefore the whole task set is not feasible. So this is it. This is my explanation for the iteration time demand analysis. I hope this helps. If you have any question, please write it down in the comment section below. Like this video, subscribe to my channel, and I'll see you in the next video.